नमस्ते बच्चों, हमेशा खुश रहो। मैं सेल्फ JVWU डॉक्टर मोनिका द्विवेदी, डिपार्टमेंट ऑफ साइंस एंड टेक्नोलॉजी, फैकल्टी ऑफ एजुकेशन एंड मेथोडोलॉजी, ज्योति विद्यापीठ वुमेन्स यूनिवर्सिटी, जयपुर. So student, in previous classes we have learned about the heterocyclic compound. So the heterocyclic compound containing namely 3 heteroatoms, sulfur, nitrogen and oxygen, and these are the cyclic organic compound containing a all carbon atom in a ring. So if at least one atom other than the carbon atom forms a part of the ring, the system then designed as a heterocyclic compound. Nitrogen, oxygen and sulfur are the most common heterocyclic atom. A numerous number of heterocyclic compounds are known, and this number increases rapidly. The heterocyclic compound are classified into the aliphatic and aromatic compound. The aliphatic heterocyclics are the cyclic analogues like amine, ether, thioether, amide, etc. Their other properties are particularly influenced by the presence of the strain in a ring. This compound generally consists of a small ring like 3 or 4 member ring and a common 5 to 7 member ring system. The aromatic heterocyclic compound in a contrast are those which have a heteroatom in the ring and behave in a similar manner to the benzene in some of their properties. These compounds also commonly apply the Huckel's rule. This state aromaticity is obtained in a cyclic conjugated and the planar system containing 4n plus 2 pi electron system. The chemistry of heterocyclic compounds is logical as that the aliphatic and aromatic compounds are studies of the great interest both from the theoretical as well as the practical point of view. So the heterocyclic compound occur widely in nature and in a variety of the known natural occurring compound. A large number of heterocyclic compounds are essential to the life. Various compounds are the alkaloids, antibiotics, essential amino acids, vitamin, hemoglobin, the hormones, and a large number of synthetic drug and dyes contain the heterocyclic ring system. And knowledge of the heterocyclic chemistry is useful in the biosynthesis of the drug metabolism. The nucleic acids are important in the biological process of the heredity and the evolution. So these are the heteroatom with the valency and the prefix will use for that. Like for the oxygen, the valency is 2 and the prefix is oxa, the heteroatom, and the valency is 3. The prefix is aza, the heteroatom as, and valency is 2 and the prefix will be used for thi. And the heteroatom Se, the valency is 2 and the prefix is selena. The heteroatom Te, valency is 2 and prefix is tulera. And the heteroatom P, valency 3, phosphor. The heteroatom As, arsenic, and the valency is 3 and the prefix will be adsa. The heteroatom silica, the valency is 4 and the prefix is Sila, and the heteroatom Ge, the valency is 4 and the prefix is Girma. Then according to ring size 3, 4, 5, 6, 7 or 8, if the ring is present with N and without N according to saturated and unsaturated compound, these are the ending of the compound's name. Now if we learn about the classification of heterocyclic compound, there are 3 member heterocyclic compound with the 1 heteroatom. The examples are azidine, azidines, oxidines, thyrine and thyrines. Okay, the 3 member heterocyclic compound with the 2 heteroatom, diazidine, and oxoazidine. The 4 member heterocyclic compound with the 1 heteroatom is azidine, oxetine, thioetine. The 5 member heterocyclic compound with the 1 heteroatom, pyrols, furans and thiophenes. The 5 member heterocyclic compound with the 2 heteroatom atoms are pyrozole, imidazole, isozole, oxazole, thiozoles. And the six-member heterocyclic compound with the one heteroatom, pyridine, pyridinium salt, and alpha and gamma pyrones. The six-member hetero compound with the two heteroatoms are pyridine and quinolysine, and pyrimidines and pyrrolysine and quinols. The seven-member heterocyclic compound azepine, oxypene, thiopene. The bicyclic rings derivatives from the pyrrole, furan, and thiophene are indoles, isodoles, indolysines, and dibenzopyroles, benzophenone, isobenzophenone, and dibenzophenone, benzothiophene, isobenzothiophene, and dibenzothiophenone. The bicyclic ring system derived from the pyridine are quinones, acridine, isoquinolines, phenanthrines, and quinolosium salts. These are some structure of three-member rings. First, in a three-member ring with a one heteroatom is azidine with a three-member compound. And this is when the azidine was first obtained in 1888 by the heating the beta bromoethylamine in the presence of the potassium hydroxide. And you can see the KOH in presence of this alkane converts into the three-member ring azidine, and the KB are removed, and H2 molecule also removed. The second is oxyrene. Oxyrene is a three-member compound. From the oxidation of the alkene, probably the simplest method of the preparation of the compound oxyrene is the direct oxidation of the ethylene by the air over a silver catalyst as the catalyst at the elevated temperature, and increasing the temperature in presence of the Eg, it will convert into the oxyrene. A simple oxidation process, oxidation on a double bond. Next is a thyrine. The thyrine is a three-member compound. Probably the most useful method of preparation of the thyrine is the 2-mercaptanol by the treating it with the phosgene in ethyl acetate and the pyridine to give the monothioethylene carbonate, which is decarboxylation leads to the thyrine. You can see in this reaction in presence of pyridine and CuCl2, this will convert into the thyrine. The acetidine 4-member compound, the cyclization method used for the acetidine preparation. The acetidine and its derivative have been prepared by the number of methods, which includes the intermolecular cyclization and the cycloaddition. In this method, the gamma bromo pyrophenyl amine in the presence of the base produce the acetidine compound. Okay. You can see the gamma bromo amine in presence of the OH, and the thermal condition it will give acetidine. The thiophene in the presence of the 1,3-dihaloalkanes, the earliest and the common method for the preparation of the thiophene involves in the reaction of the 1,3-dihaloalkanes with the sodium or the potassium sulfide. This reaction is generally carried out in an alcohol-water mixture at 70 degrees. Okay. The next is oxygen. Oxygen is a 4-member compound. The cyclization reaction, it is a direct route for the preparation of the oxygen in the reaction of the halohydrazine in presence of the base form and 2,2-diethyl oxalate. Okay, so it will give the 2,2-diethyl oxalate. The pyrroles, a 5-member compound from the furan. Commercially, the pyrrole is obtained from the fractional distillation of the coal tar or bone oil. Alternatively, it can be obtained from the furan by the passing it over the ammonia and the steam and heated at the 400 degree in the presence of aluminium oxide catalyst. The primary amine may be employed to prepare one substituted pyrrole. Okay, so this is the reaction for it. Next is the furan, the five-member compound. From the furan, the most important source of the furan is furfural. Furfural, the latter is available by the acid hydrolysis of the polysaccharides present in oat, husk, and the corn cobs. These are degraded to the pantenones, which are subsequently converted to the furfurans on the further treatment with the acid. The furfurans can also be converted directly to the furan by its gas phase decarboxylation in presence of the palladium and the charcoal. The Thiophenes, the five-member ring, the sodium succinate, the classical method for the preparation of the thiophene in the laboratory consists of the heating a mixture of the sodium succinate in the presence of the phosphorus trisulfide. This is the reaction. The pyridine, the six-member ring, the 6-benzyl 3,5-dichloro-2H1,4-oxene 2O21 on the reflection with the phenyl acetylene in toluene yielded a high substituent pyridine. This is the reaction. The azepine seven-member compound from nitrobenzene by its deoxygenation with the tributyl phosphine initially forms an aryl nitrite. This is accomplished with the primary alcohol leads to the formation of the 2-alkoxy 3H azepine. This is the reaction. Next is the oxypene seven-member compound. The oxypene was first prepared by the treatment of 1,2-epoxy-4,5-dibromocyclohexane with a mild dehydroxylation agent. This is the reaction of the preparation of the oxypene. The thiopene seven-member ring. This reaction Weinberg and Hadler reported that the 2,3,4,5 tetramethyl thiophene and dicyanoacetylene in the presence of the aluminum chloride yielded the thiopene derivative. This is the reaction. Now the indole, this is the bicyclic ring system derived from the pyrrole. The system is in this reaction. The preparation of the indole and its derivative involves the base catalyzed consideration of the orthonitrotoluene with the oxalic and ester in the presence of the sodium ethoxide from the orthonitrophenyl purate. This on the hydrolysis give a corresponding acid. This on the reductive ZnCH3COS cyclization yielded the indole. So this is the reaction mechanism. Now the next is the benzophenone. Benzophenone is a bicyclic ring system derived from the furan. From the coumarine, this method involves initially the bromonation from the coumarine to the 3,4-dibromocoumarine, followed by the treatment with the alkali and the cumarolytic acid. The acid decarboxylates to the benzofuran. This is the reaction. Now next is the benzothiophene, the bicyclic ring system derived from the thiophene. From orthomercapto beta chlorostyrene, the orthomercapto beta chlorostyrene on the refluxing with the alcoholic solution of the alkyl cyclides give the benzothiophene. Now the acridine is a bicyclic ring derived from the pyridine. From the diphenylamine 2-carboxylic acid. The orthochlorobenzoic acid is first considered with the alanine in the presence of a base to the yield diphenylamine 2-carboxylic acid. The acid is cyclized in the presence of the sulfuric acid and acridone, whereas the reaction with the phosphorus oxochloride gives the 9-chloroacridine. The reaction of the acridines and the 9-chloroacridine with the appropriate reagent produce the acridine. This is the oxidation by the air or the ferric chloride lead to acridine. This is the reaction to formation of the acridine. Now the phenanthrone and the bicyclic derivative from the pyridine, the cyclodehydrogenation of the acyl orthoamine diphenyl in the presence of the phosphorus oxochloride, and this is the reaction of the preparation of the phenyl hydrazine. So this is all about the heterocyclic compounds. Thank you.